Well, in this example, I want to solve for y squared. Remember, if this is a function, I should be able to solve for y squared and get an expression that you can only get one output from. So let's do that. Let's solve for y. To solve for y, I'm going to subtract the x squared from both sides. I get y squared equals 9 minus x squared. Now I use what's called the square root property. Remember, in the square root property, this is one of those fundamental math, algebra skills that I want you to be familiar with. In the square root property, we take, some people call it taking the square root of both sides of the equation. It's not really what we're doing, because when you take the square root, you need to incorporate both a plus and a minus. When you square something, I'll give you an example here. If I had a squared equals 25, the question is what number squared is 25? Well, there's two of them. There's positive 5 and negative 5, right? Plus or minus 5. Well, that's essentially the square root property. It says when you have a quantity squared equal to a number, you have to use plus or minus the square root of that number to simplify. So some people would go square root of both sides. Well, that kind of makes sense, except you can't forget the plus or minus. Same thing here. Square root property would say that the answer, when you take the square root, would be plus or minus the square root of 9 minus x squared. Okay, it's a bit of a complicated expression, but that's mathematically accurate. The problem is this: if I try to plug in x values, let's say x is equal to what's a good number here? Let's say x is equal to 0. That'd be a good one. That's a good number. If x is equal to 0, then y is going to be plus or minus the square root of 9 minus 0 squared. Well, 0 squared is 0, 9 minus 0 is 9. So that's plus or minus square root of 9, which is plus or minus 3. And then you say, well, which one is it? Plus 3 or minus 3? Problem is, we've got two possible outputs for the same input. So on this relation, this original relation, the ordered pairs 0, 3 and 0, negative 3 are both on the graph. Okay, they're both ordered pairs in the relation. The problem is I have the same input corresponding to two different outputs. That can't happen. That's a violation of the definition of a function. And so this original relationship is not a function. And it really comes down to this plus or minus. When you have that, either one, there. When you have that plus or minus option, you create the potential for more than one output. More than one output from the same input. Okay, so that relation is not a function. Okay, not a function. Now, it is a relation. It does have a domain. It does have a range. But it is not a function. This is a type of relation that we're going to talk about when we get into conic sections. It's actually a circle. The graph of this thing is that was not very well drawn, but either way, quickly. It is a circle of radius 3 centered at the origin. The square root of that 9 gives you the radius. And it's centered at the origin. So assume that's centered there. Okay? So it is a graph. It does have a graph, but it is not a function. Okay. Another thing that's kind of interesting, a way to represent relations. You have these interesting diagrams where you put elements of the domain on one side, elements of the range on the other side, and then draw arrows relating them. Okay, you'll see this very common in the textbook. I'm sure it'll be in my math lab somewhere. And it's just kind of a neat idea. In this case, in the domain, well, the domain has a lot of different things. In fact, if I'm thinking about that right, well, the inputs, you could input anything from -3 to 3, I believe. Furnace is kicking on. So, I am in my basement of my house, so if you hear some weird noises going on, I got my furnace kicking on, I got my sump pump going, these things happen. Probably kids running around upstairs. So, throughout the semester, that may be something. I startled a little bit. Anyway, so our domain here is all numbers between -3 and 3. Now I'm not going to list them all out because there's an infinite number of numbers in there, but I could list a couple of them out, like 0 or 1 or -3. The number 0 corresponds to both +3 and -3 when you plug it in, right? And so sometimes you'll see these diagrams with arrows. It just means that whatever you plugged in is the inputs are here, the corresponding outputs are connected to an arrow on the other side. And so what's going to end up happening is that most of these domain values are going to have 2 arrows, 2 things they're going to. Now, to be a function, they can only have 1. And so another really interesting feature of functions is that we can combine them in many different ways, particularly using the operations of addition, subtraction, multiplying, and divide, multiplication and division, I should say. The 4 main operations that we use on numbers can also be used on functions. As we move later into the course, you're also going to see another operation on functions called composition. We're not going to see that just yet. But adding, subtracting, multiplying, and dividing functions. So if you imagine having 2 functions, let's take f of x is, let's go with that 2x minus 3 example from earlier. And let's take another function, let's call it g of x, so we're having a different letter there. G of x is equal to, let's do something a little bit different. Well, let's do that 2x over x minus 5 like we saw earlier. Okay. Yeah, why not? Good enough. We'll see what happens here. And so what I want to do is find the new function I would get if I were to add those 2 together, f plus g. Okay, f plus g of x. That's going to be a new function. Well, the general idea for adding functions is that you take one function, add the other function, combine like terms, add them however you would need to. So here, we would be writing it out, and now I might need all 3 of my markers. I'm going to try to color coordinate this. We'll see how it goes, and if I have enough space to pull this off. So we're really looking, f plus g of x is really f of x plus g of x. Okay, so we're going to take the first function there, f of x, that is 2x minus 3, and add to that the second function, which is 2x over x minus 5. Okay, now how do I add these 2 functions? Well, I'd like to get them into one fraction. To do that, I need to get a common denominator. Well, I could think of this first function as being divided by 1, right? Just like a whole number is, the number 12 is 12 over 1. This is 2x minus 3 over 1. To get a common denominator, I need to multiply the top and bottom of this fraction by x minus 5. So I'd multiply here by x minus 5. I'd multiply this one by x minus 5. Okay? Got to multiply by the other denominator to get a common denominator here. And so if I think about this new fraction, it's going to get to be kind of big. So I'm going to have Actually, I'm going to take this off to the side. I'm going to have 2x minus 3 multiplied by x minus 5. That's going to be the numerator of the first fraction. So when I multiply these, I get 2x squared minus 10x minus 3x plus 15. I could combine the two terms in the middle. And that would give me 2x squared minus 13x plus 15. And that is all over x minus 5. Probably could have done that in blue, doesn't matter. Then the other side there is going to still be 2x over x minus 5. Now they have a common denominator, and once you have a common denominator, you just add the numerators together and keep the common denominator. So here we'd get, let's see, 2x squared, I get minus 13x plus 2x. Those are common, or those are like terms, so I can add them. Minus 13 plus 2 is minus 11, so it'd be minus 11x plus 15 all over the x minus 5. Okay. Now, if this factors and reduces, we could do that, and it does, I think, unless I'm looking at that wrong. I think this one actually reduces nicely. Let's see what happens. I'm going to need a little more space here. Okay, so I've got it down to that so far. So can I factor that numerator? That's the question. Well, we're getting a lot of practice with a lot of cool algebra stuff, review stuff here in this problem. So if you'll recall factoring, we're trying to break a polynomial down into smaller polynomials. The goal of this is going to be to cancel potentially. So the question is x minus 5 a factor of that numerator? Maybe, maybe not. Let's see. So I need to factor out 2x squared minus 11x plus 15. And to factor this, if the leading coefficient is not 1, I need to use something called the AC method. Some of you may have seen the AC method before, or a variety of other methods for factoring. A times C, remember, if this is ax squared plus bx plus c, AC is 30, that's 2 times 15. And then to factor, we need factors of 30 to add up to negative 11. Oh, it's not going to work. I was thinking that would work with 6 and 5. Problem is, with the 6 and the 5, or 5 and 6, to get them to multiply to 30, they both either have to be positive or they both have to be negative. Oh, no, that will work. What am I thinking? Yeah. Negative 5, negative 6 will work. Cool. Okay. Well, negative 5, negative 6. So we get, so there's something called the AC method. There's also something that I like to use called the modified AC method. I'm going to use that here. The modified AC method basically says my answer is going to be 2 sets of parentheses. The 2x squared breaks down. Now I know that I'm going to need an x term in each of these first two terms, right? X times x will be the x squared. The modified AC is going to take that leading coefficient and put it in both spots. Now that's not going to be my final answer because 2 times 2 is 4, not 2. I'm going to have to divide out a 2 at some point, but I'll show you where that comes from. Then I put the minus 5 and the minus 6 as the constants in the parentheses. Wherever there's a common factor, I divide out the common factor. 2 and 6 have a common factor of 2. That's my extra 2 that I need to factor out. And if I do that, I still have 2x minus 5 here. This side is x, this side is 3. X minus 3 is my other factor. Now you can check this, make sure I factored it right. 2x minus 5 times x minus 3. Well, 2x times x is 2x squared. 2x times minus 3 is minus 6x. Minus 5 times x is minus 5x. That combination gives me the negative 11. The negative 5, negative 3 gives me the positive 15. So this will work out when I redistribute. The problem is, when I put those factors in up top, 2x minus 5 and x minus 3, they don't cancel with the one on the bottom. Remember, when canceling in a rational expression like this, the numerator and the denominator have to have the exact same factor, the whole factor. So 2x minus 5, that whole factor does not show up on the bottom. X minus 3, that whole factor does not show up on the bottom. And x minus 5, that whole factor does not show up on top. Okay? It has to be exactly the whole factor in order to cancel. So here, we're done, simplified. We don't have to factor any further or cancel. Okay? That was kind of a complicated example. It was good to practice some of that stuff, but it's a little bit complicated. You may see some that are a little bit easier than that. You may see some that are hard like this too. There's going to be some rational functions. There's going to be some radicals, some roots, square roots, and stuff like that. Let's go through just to bust through a couple of these a little bit faster. Let's change the functions up so you can see how this works. Let's take f of x to be 5x plus 1, and let's take g of x to be x squared minus 2. All right, and so here we can do some combining. Again, we could look at f of x. Oh, we could look at f plus g of x. We could look at f minus g of x. We could do f times g of x. Or we could do, and I'm running out of room, maybe I'll do this later, f divided by g of x. I'll come back to that one. So if I wanted to find f plus g of x, I just take the first function, f of x, and add the second function, g of x, and try to keep my colors consistent here. The f function is 5x plus 1. Then the g function is x squared minus 2. In most of these, it's not going to be as hard as finding common denominators. A lot of these are just going to be combining like terms. And so here, I got an x squared. That's my highest power of x. I've got a 5x. And then I've got a 1 and a minus 2. That makes a minus 1. Okay, so I'm just combining like terms at that point to create a new function. Okay. Now I've got f minus g. Let's try that one out. So that, of course, is going to be f of x minus g of x. And when I put the first function in, I get 5x plus 1. Then I get a minus. Now this minus has to apply to both terms in the g of x function, the entire g of x. So I like to put the g of x, whatever the following one is, in parentheses, so that I know that that minus applies to the whole thing. Then I distribute the minus, okay, and that's going to give me 5x plus 1 minus x squared plus 2, right? Negative x squared and negative negative makes positive 2. And then I combine my like terms. So after distributing, then we combine things. We're going to get a negative x squared. We're going to get a 5x. And 1 and 2 make 3, so that makes it 3. So x squared, negative x squared plus 5x plus 3. Okay, so again, a new function, from the original 2. Now, the next one is the product of f and g, f times g. So when I do that, it's going to be f of x times g of x. And of course, with 2 binomials, we're just going to use the distributive property, or some of you may have be familiar with the FOIL method. And so here, we're going to have 5x plus 1 times x squared minus 2. We're going to distribute that out and combine like terms. So 5x times x squared is 5x cubed. 5x times minus 2 is minus 10x. Then we get 1 times x squared is just x squared. And 1 times minus 2 is a minus 2. I don't actually have any terms to combine because they're all unlike terms. I might just reorder them so that they're in decreasing power of x. That's kind of our common way to write polynomials. So 5x cubed plus x squared minus 10x minus 2. That would be a pretty good answer to that one. Okay. Now, before I move on to the division, I do want to show you something, and I'll stick maybe with the addition one here for just a moment. Let's get rid of these other 2. Okay. We can also find values, find something like f plus g of 3, for instance, f plus g of 3. All you got to do is plug 3 into that new function that we just found. So it would be 3 squared plus 5 times 3 minus 1. All right, so you plug the 3 into the new function. So we can evaluate these as well, just like we did with anything else. This would be, what, 3 squared is 9, 5 times 3 is 15, minus 1, looks like a weird looking 1 right there. There. 9 plus 5 is 24. 24 minus 1 is 23. Right? So f plus g of 3 is 23. You could also go about that a different way. That is, you could plug the 3 into each of the original functions and then add them together at the end. Just to show you that you'll get the same answer. You'll still get 23 doing it that way. You could do f of 3, and just taking that 3. That will give you 5 times 3 plus 1. 15 plus 1 is 16. Okay. And then you could do g of 3. Color coordinate a little bit there. G of 3 is, be consistent, 3 squared minus 2. So 3 squared minus 2. Well, 3 squared is 9. 9 minus 2 is 7. And then from there, you could add those 2 results. So f plus g of 3 would be the 16 plus the 7, which is 23. Okay, same answer, different way of going about it. All right. Okay, and then finally, I wanted to show you the division. Right. Careful what I erase here. Okay, so that would be the function f over g of x. All right, and now how I would write that is to write out f of x over g of x. And now just remember too, it doesn't have to be f over g, it could be g over f. You could do g times f. You can change the order of these things, but it will change the function. So you don't want to just scramble them all up all the time. I'm just saying you got to follow what's written here, but I may have written g over f instead. So just be aware of what's being written first, what's being written second. Okay, so on that note, I would take, let's see, 5x plus 1 on top. I would write the x squared minus 2 on the bottom. And then I would try to simplify. Well, this function is not going to simplify because neither of these polynomials is factorable. Okay, so I won't be able to simplify it. If it was simplifiable, if I could factor the top, factor the bottom, and cancel any common factors, I would want to do that. However, in this case, it's not going to be doable. And probably in a lot of these, you won't be able to cancel them. So I would just leave it alone. This is it. Sometimes these division problems are even easier than the multiplication ones, just because there's less work to do. Okay, so that gives you a pretty good idea, a pretty good overall summary of functions, I think, just to get you familiar with these different techniques. There are going to be things in this section that are not covered in the videos, just because there isn't enough time for me to do an example of everything. You may see some absolute values, some roots, some other things show up here. So just be aware of that. Work through them as best you can. If you do need to ask me questions, email me. As you're going through the homework, there should be an option to email your instructor if you're getting stuck. You do have access to the ebook in my math lab, and you can look up examples in the book as well. So utilize those features.